Good morning, dear students. Last class we have seen sublimation and the effect of change of pressure. How the pressure helps to change the states of matter we have seen. And as a conclusion, at the end we have seen how the interconversion of the three states of matter happen. Hmm? Through vaporization, sublimation, fusion, solidification, condensation, and sublimation. We have seen and we have defined each day. And today we are going to complete the lesson with the last topic, evaporation. Evaporation. You know, do you think that always we have already learned about the heat and pressure, how heat and pressure helps to change the states of matter we have seen already. And my question is, do we need always this heat and pressure for the change of states of matter? Can you think it? Another question that we have to reflect in this point is um, liquid. When the liquid states change to vapor state without the liquid reaching the boiling point, how it is possible? Is it possible to change the states from liquid to vapor without the liquid reaching the boiling point? Usually, you know, when how the liquid reaches to vapor stage after reaching the boiling point. Liquid will reach the boiling point, then it becomes started to vaporize. And we come back to the first question. Our question was, do we need always heat or pressure? Just imagine one example. We have one bucket of water and we keep it outside, and after some time you will see, if you measure the amount of water, you will see there is a decrease of the amount of water, isn't it? Another example, you dry, you leave for drying your dresses, your wet dresses you leave for drying, and what happens? It will dry after some time. There also happens this phenomenon, this process. The water, when we leave uncovered, the water will vaporize. And this term, this is called evaporation. And we are going to see um, little more detailed way. Always remember that particles of matter moving and never at rest. That we have already learned. The particles, in every matter there are particles, and these are moving and they are not taking any rest. Okay. At a given temperature in any gas or liquid or solid, there are particles with a different kinetic energy. So, remember, in a particular temperature, in a gas, when we speak about kinetic energy, speaking about the moving quality, moving. Say, always remember kinetic energy with the moving, something moving. Okay. So, at a given temperature, any gas or liquid or solid, there are particles with a different kinetic energy. For example, for gas it has one kinetic energy, liquid has another kinetic energy, solid has another kinetic energy. For example, in the gas, the particles have more kinetic energy, isn't it? Okay, good. In the case of liquids, small particles of the surface have more kinetic energy. Remember, in the case of liquids, small particles of the surface have more kinetic energy. Mhm. Is able to break away from the is able to break away from the force of attraction of other particles and gets converted into vapor. You remember, in the case of liquids, let us take um, example of the bucket of one bucket of water. Okay, I will explain detail. And what do you say? Small particles of the surface have more kinetic energy. There one word is missing. You remember, in the case of liquids, small fraction of particles of the surface have more kinetic energy. Small fraction of particles. Small part. Just remember, small part of particles of the surface. You know, we have water in a bucket, and the surface, the surface water, what we see, the outside, isn't it? That water have what happen? Have more kinetic energy than the water that is down. Remember? And this fraction of this part of particles of water that is on the surface of the water in the bucket is able to break away from the force of attraction. What happens? This will have more kinetic energy. So it will have the tendency to break away from the force of attraction of other particles and gets converted into vapor. They escape. Did you understand? And they escape. The phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. What is evaporation? The phenomenon of change of liquid into vapor at any temperature, but it should be below its boiling point is called evaporation. Understood? Very good. Now let us see what are the factors that affect the evaporation. There are four factors that we are going to learn. The first one, an increase of surface area. What is surface area? The area that which, for example, a bucket of water, and the water that has the contact with the surface, that has the contact with the air, the atmosphere, that is surface area of the water that is seen, the outside part. Always remember, evaporation is a surface phenomenon. Okay, so if the surface area is increased, the rate of evaporation increases. Understand? If the surface area is increased, the rate of evaporation increases. One good example is we have a bucket of water. The same amount of water we are taking also in a big biryani vessel, and we keep it outside for a long time, and we go and measure uh, both water in the sense the water that was in the bucket and water that was in the biryani big vessel. What will happen? You will notice the more water will be or would have evaporated from the big vessel. Why? The surface area was bigger there comparing with a bucket of water. Another best example is spreading clothes to dry up. Your mother wash the clothes, clean the clothes, and she does not go to the room and fold it and keep in the cupboard the dress. But what she does, she makes it dry. How? Spreading it, not folding it, spreading the clothes. When we spread, what happens? The surface area, the area in which the water molecules, the area in which the dress have a contact with air, that is surface area. The surface area will be increased when we spread the cloth. So the clothes will dry up fast. Another one, the next factor that affects evaporation is the increase of temperature, that we know already. When we increase the temperature, what happens? The kinetic energy increases. When there is more kinetic energy, the water, what happens? With the increase of the temperature, more number of particles get kinetic energy, so that it will escape, the water molecules will escape to the vapor state. It will convert to the vapor state. Very good. The next factor that affects the evaporation is decrease in humidity. Decrease in humidity. First of all, you must know what is humidity. Humidity is nothing but it is the amount of water present in the air. Always remember, in the air there is certain amount of water present. Okay. So what is humidity? This water. The water content of the air is called humidity. Always remember, The air that is around us cannot hold more than a definite amount of water at a given temperature. It cannot hold, it can hold a certain amount of water. It cannot hold more than that scale. So, if the amount of water in air already high, the rate of evaporation decreases naturally. Remember, so it is very simple as it is. So, when there is more water content in the atmosphere, in the air, the clothes or the things will not dry fast. That you know very well. Why? Because the rate of evaporation will be decreased in that time, especially in the rainy season. You remember, in the rainy season, already because of this rain and so on, already our atmosphere will be wet. That means lot of water content will be there already. That means a lot of humidity will be the rate of water content will be more in the atmosphere, in the air. So when there is more water in the air, the rate of evaporation will be less. It will be decreased. That is why during the rainy season, the clothes will not dry fast. Okay? Shall we go to next? Next factor that affects the evaporation is an increase in the wind speed. When there is more wind, the evaporation happens fast. Clothes dry faster on a windy day, that we know. That is why we keep the dress outside of the pump, the outside of the room to dry. With the increase in the wind speed, what happens? What happens when there is wind? This wind will take away all the water contents, all the water that is around the clothes, that is around the atmosphere, that is around the air. So when there is no water content in the air, that happen, the evaporation happen faster. Understood? Good. So now we are going to see how does evaporation cause cooling. When there is evaporation, it causes cooling. Remember, the particles of the liquid absorb energy from the surrounding to regain the energy lost during evaporation. So remember that when the evaporation happens, it loses energy. Okay, this absorption of energy from the surrounding make the surrounding cold. So what happens? It absorbs the energy from the surroundings to make the surroundings cold. Example of acetone spray, when we apply spray and so on. Another question, why should we wear cotton clothes in summer? We prefer always cotton clothes in the summer, isn't it? So why? You know, during summer we sweat more, and during evaporation, what happens? The particles at the surface of the liquid gain energy from the surroundings and change into vapor. Cotton being a good absorber of water, what happens? It helps to absorb the sweat and exposing it to the atmosphere for easy evaporation. What happens? This cotton is a good absorber of sweat, the water, and it absorbs, and after absorption it exposed to the air, atmosphere for the evaporation. That is why it makes a cool feeling. Good. That is why we also prefer cotton clothes in the summer season. Good. Next, why do we see water droplets on the outer surface of a glass containing ice cold water? Did you understand the question? What they are trying to ask us? For example, I have a bottle of water. I keep it in the freezer, and after some time I take it back and keep it outside for some time, and you will see lot of water droplets around that bottle. Remember that water droplets is not coming from inside the bottle. The inside the bottle, the same amount of quantity of water will be there. Then how that water droplets come outside uh, of the bottle? It is due to a process, due to a phenomenon called condensation. What is condensation? Condensation is the process of change of state from gas to liquid. Gas to liquid. I'm going to explain how it happened. Already we have said that there is a lot of water present in the air, in the atmosphere that is around us. So what happened when I keep an ice cold water, one bottle of water outside? What happened? This water, this ice cold water will have contact with the air that is present. And when there is a contact between this air, this water content air with this ice cold water, this air loses energy and gets converted to liquid state, and we see as water droplets around the bottle, around the glass of water. Have you understood? Simple as it is. Good. And we have complete this lesson, first lesson. Remember, we have studied there are three states of matter, but nowadays the scientists are talking about five states of matter, hmm, that are solid, liquid, gas, and plasma and both Einstein condensate. Hmm. You must know, you just read the textbook that is given in the end of the chapter about the plasma state and Bose-Einstein condensate. That is the fourth and fifth states of matter. So your homework, your task of today is you have to define what is evaporation and what are the factors affecting evaporation, and those questions that is given in the slides. That means, how does evaporation cause cooling? Why should we wear cotton gloves in summer season? Why do we see water droplets on the outer surface of the glass containing ice cold water, etc.? Thank you. See you. One more thing I forgot to say. We have completed one lesson, and it is a time to evaluate us. We evaluate ourselves. How did we understand things? How did we um, grasp the concepts? So we will have next week, we will have a self evaluation. So please prepare yourself and study well. Thank you.